Welcome back, learners, teachers in physical sciences. We are now in the section of Doppler effect. We want to try to solve some problems after we learned that normally Doppler always takes place when there's a relative motion, and also we can use three formulas to deal with Doppler. And also in Doppler it's about motion, frequency, and wavelength. I think the explanation will be based on the three, where one is given and then you have to explain using the remaining two. And also we learned about the definition of Doppler and as well as the uses of Doppler. I think in a nutshell those are the ones. Otherwise questions will always give us more. And there's a Doppler of light as well. The Doppler of light, I think, let's start with the Doppler of light before we can deal with the Doppler effects problem solving. In a nutshell, the Doppler of light will be very small topic in this case. A Doppler of light, which will talk about the distant stars. Let's say we are on Earth. This is the Earth, and then we have got the rainbow. Remember, the rainbow mainly has got the three main colors, which is red, green, and blue. If it's more blue, it will be indigo. If it's more red, it will be violet. If it's more red, between green and red, it will be orange. If it's more green, it will be yellow. That is a row of beef, meaning that now this is a spectrum. If I've got the so-called distant star, or the galaxy. Galaxy is just a group of stars now. In this case, now if I'm observing from Earth one day, then the first observation I found that the frequency detected of those stars is said to be 2000. I'm just hypothetically saying so. Second observation will be, let's say the detected frequency becomes 1.8 hertz. Therefore, if we use Doppler to explain this movement, we know that when the frequency decreases, then it means that now the movement is away. If the movement is away, then the frequency, we said, decreases, the wavelength increases. And in this case, the universe will be now expanding. Then this is called redshift. Why redshift? Is because now the stars, because they are moving away, they are moving towards the red end of the spectrum. That's why we call it redshift. If you happen that maybe in your second observation, then you find instead of this one, you find that the frequency is now 2500 hertz. Therefore, it means that from 2000 to 2005, it's increasing. Once the frequency is increasing, it means that the movement is towards the Earth. And if it's towards the Earth, then we know that is when the frequency is increasing, and then the wavelength will decrease, and then the universe will be now contracting. Therefore, this is called the blue shift. What you should know in this case is very important, is that what is examinable is red shift, not the blue shift. You will find the blue shift in the June exam or trial because the deviation is allowed there, but in the final analysis, final exam, they will be revolving around red shift. Fine, that's the blue shift, when the stars are moving towards the blue end of the spectrum. That is in this case. Or if they can just say, fine, we've got this three observations. Let's say this is the original is here, and then we have got like these two lines and this, and then in this case you have this and this is blue, this is red, blue, red, blue, red. Now you have this, and this, and then if you move from this side, or if you move this side, you find, let's say, this and this and this one. Now they say explain what will be the first part from 1 to 2. 1 to 2, then now you can see the lines here, they are moving towards the blue end. This will be the blue shift, and that this will be the blue shift. And then from here to here, you can see the double line are moving towards the right, which means that they are moving towards the red end of the spectrum. This will be the red shift. That is how, when you are using this type of scenarios, which can be given. So fine, you know how to explain the red shift. You say red shift, the movement is away, frequency is decreasing, the wavelength is increasing, the universe is expanding. So mainly when we want to explain, in this case, then we said there are only three things: motion, yes, frequency, and the wavelength. So one of the three will be given, so that you explain using the other two. That's how we explain, either using Doppler in this case. Fine, with this one, we can now go to the question and see whether can we manage now to answer this question. Fine, here is the question from the recent question paper. They say to us, an ambulance approaches an accident scene. Approaches, you have to underline the word approaches. Movement is towards. Then the x and z at constant velocity. A siren of the ambulance emits this sound waves with a constant unknown frequency. Fs is not known. A detector at the scene measures the frequency as 1.07 times the frequency of the siren. This case now, if we use the 5, then which is FL, FS, V, and then VL and VS. These are the 5. Again, this one now, FS is just FS. This one is 1.07 FS according to the statement. Yes, and then they are saying that's all the what is given so far. 6.1. They say state. Yeah, let's continue. The first question says state Doppler effect for sound in words. There are two easy definitions that you can do. You say Doppler is just the change in frequency. That's the first part. Change in frequency as detected of sound. Change in frequency of sound as detected by the listener due to the relative motion between the listener and sound source, or the change in frequency of sound is detected by the listener due to the listener and the sound source moving at different velocities to the medium of sound propagation. That is a definition of Doppler. The first question calculation, they say calculate the speed at which the ambulance approaches the accident scene. Use the speed of sound in air as 340. This is 340. Now we know that if one is moving, another one is stationary, remember. In this case, the ambulance is the one that is approaching, therefore the listener will be stationary in this case, and then we're calculating the speed of this. Now just write the Doppler equation, V plus or minus VL divided by V plus or minus Vs multiplied by Fs. Therefore this is 1.07 equals to 340. The motion is towards, therefore I'll start with positive, divide by 340 minus 0, then this one will be, oh sorry, minus Vs. This one will be plus 0 multiplied by Fs. This is Fs, this is Fs. They cancel out. And now you need your calculator in this case, and then you will end up with a Vs your 30, around 30 meters per second. I think that will be the case when you use the calculator in this case. Fine. Now the next question, which is 6.3, let's go 6.3. Explain in terms of wave motion, frequency detected by the detector. Why frequency detected by the detector is higher than the frequency of the source. Remember we said there are three things. Now motion, frequency, and wavelength. Now already the frequency they say is higher, therefore you just mention 2. Motion is towards or motion of ambulance of source is towards the listener, to be precise, towards the listener. The second point will be the wavelength of those sound waves is in this case decreasing, or the wavelength are compressed. Fine. 6.4. They're saying to us, state 2 uses of Doppler flow meter in humans. Just say Doppler in humans. I think we will have Doppler flow meter, which used to measure the rate of blood flow. Fine. The second one is used in sauna to measure the heartbeat of fetus. Fine. 6.5, which is the last one. They say to us, in a line in a hydrogen spectrum has a frequency of 7.55 by 10 to exponent 14 hertz. When measured in a laboratory, the same line in the light of a star has a frequency of 7.23. Just look at the two frequencies now. So it means that the frequency is decreasing. If the frequency is decreasing, Doppler says the movement will be obviously away. They're asking you to say, is this star moving towards or away from the earth? It will be away. Fine. Explain your answer. Then, because already we know that the frequency is decreasing, we are left with wavelength. Therefore, the wavelength increases. So the movement is away, and because already they are saying the frequency is decreasing, then the wavelength will increase. That is all for this question. I hope it makes sense. For the Doppler, is one of the easiest section in this, and then which is straightforward. But always remember that when you explain, you are using motion, frequency, and wavelength. It will make life easier for you if you remember that one. That was question number 6. We'll do the other questions in the coming sessions. Hopefully, it becomes clearer and clearer dealing with Doppler. Thank you.